Hey guys, it's Miss Castor. Go ahead and take Cornell style notes over linear functions. That should be your topic or objective or title of your page. Make sure that your name is written on your paper, you have algebra, and then you have whatever class period I see you, and then today's date, which is October 28th. Okay, the first thing we're going to do is define what linear is. Linear is a function with a constant rate of change. Something to take note of is that a linear function will always form a line. Here's a nifty little way to remember it. The word linear has the word line in it. So, on a graph it will always form a line. Rate of change can be defined as the change in y over change in x. It is the ratio. Another way that you will see it written is this symbol. It's the delta symbol, and all that means is change in y over the change in x. We're going to look at linear versus nonlinear. The first we're going to look at is graphs. So with graphs, linear, it's going to form a line. So anything that looks like this or like this, those are both lines and they are linear. Nonlinear is going to look like this. Anything with a curve. Okay, so linear is a line. Nonlinear is anything with a curve. When looking at equations, we start with the linear parent function, which is y equals x. This is my parent function. And when looking at equations, it's linear if the only thing that I do is add, subtract, multiply, or divide. If I do any of these four operations to this function, y equals x, then it's going to be linear. So examples are y equals 3x plus 2. Because all I did was multiply by 3 and then add 2. So it's going to be linear. Another example would be y equals negative 4x minus 17. Those are both linear. All I'm doing is multiplying and then subtracting. An example of a nonlinear equation would be y equals x squared minus 4, because I'm doing more than just adding, subtracting, multiplying, or dividing. Another example would be y equals square root of x. These two are nonlinear because I'm doing more than only adding, subtracting, multiplying, or dividing with my x. Okay, looking at tables, I want you to find the rate of change for both. So you're going to find the change of y and the change in x. A way that you can do this really easily is by saying, what did I do to get from 1 to 2? Well, I added 1. 2 to 3, I added 1. 3 to 4, I added 1. And then do the same thing with y. What did I do to get from 3 to 6? I added 3, I added 3, and I added 3. Now, put that in a ratio of the change in y over the change in x. Do that for both of these and find the rate of change for both. And then tell whether you think it is linear or nonlinear based on that. And that's it. I will see you guys in class.